is over how to multiply decimals. Before that, let's review everything we remember about ordering rational numbers. You have a scientist who recorded the differences in weights of a mice after a change in the diet and exercise routine. The differences were the following: -1/2, 23 hundredths, -4/10, and 1/3. Put them from least to greatest. So we have a number line. Zeros here, -1 here, 1 here. So -1/2. Half of a dollar is 50 cents. So it's -50. So that'd be going right there. 23 hundredths is between 0 and 1. -4/10 is the same as saying -40 hundredths. So remember, when you count negative, you're counting backward, so it must go right here before the 50 hundredths. 1/3. God, we've seen that so many times. Isn't it 33 hundredths repeating? So it goes right here. And what do you remember about a number line? It goes from least to greatest. So least to greatest. So you have -50 hundredths, -40 hundredths, 23 hundredths, 33 hundredths. All right, so we're going to first talk about using models to teach you how to multiply decimals. What's 3 times 15 hundredths? That is the same as saying 3 groups of 15 hundredths. So I would like you to shade in 15 hundredths. This grid represents one whole, so each square represents a hundredths. That's one group of 15 hundredths, 2 groups of 15 hundredths, 3 groups of 15 hundredths. So if you count each and give you one, there's 45 hundredths. So 3 groups of 15 hundredths are equal to 4,500. So 3 times 1500 is 4,500 hundredths. I wonder how I came up with that. 3 times 1500 became 4,500 hundredths. Seemed like we had 15, like 3 of them. 15, 15, 15. In the decimal place, I don't know. Hopefully I'll find out eventually. Something about the place values. Let's try another example. 5 times 8 hundredths. So I shaded 8 hundredths. This is 8 hundredths. 5 times 800 means 5 groups of 800. So this is the second group of 800. This is the third group of 800. This is the fourth group of 800. And this is the fifth group of 800. So that equals to 40 hundredths are shaded. Or you could say 4/10. How did I come up with that? So 5 groups of 800s are equal to 40 hundredths of 4/10. 5 times 800 is 40 hundredths. How did I come up with that without using a 10 by 10 grid? Let's see. 8 of them times 5 is 40. But how did this decimal go here? Let's see. There's 2 places here, and there's 2. You know what? Hopefully I'll get it to the next one. What's 2/10 times 3/10? So you shaded 3/10. 1/10, 2/10, 3/10. Remember, 3/10 is the same thing as saying 30 hundredths. Then you shade 2/10 of this. Here's 1/10 of this and 2/10. How many hundredths are shaded crisscross twice? 1, 2, 3, 4, 5, 6 of them. 6 hundredths. So here's 3/10. 2 parts of it, or 2/10 of it, 2 parts of the 3/10 is 6 of them, 6 hundredths. So 2/10 times 3/10 is equal to 6 hundredths. How did they come up with this? Let's see. I can see where the 6 came from. 2 times 3 is 6. There's 2 numbers behind this decimal point, but there's only 1 number here and 1 number here behind that decimal point. Not quite sure. Hopefully I get to do the next one. We have 4 tenths times 7 tenths. So I shade in 7 tenths. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths. What is 4 tenths or 4 parts of this 7 tenths? Here's 1 part, 2 part, 3 part, 4 part. How many of these hundreds are shaded crisscross twice? 4 times 7 is 28 hundredths. So 4 tenths times 7 tenths is 28 hundredths. How did I come up with this? Let's see, 4 times 7 is 28. I understand that part. But why are there 2 places here and there's only 1 place, 1 place? Seems like tenths place times tenths place, tenths times 10 is a hundredths place. So we multiply different place values, becomes a new place value. Tenths times tenths is a hundredths. Tenths times tenths is a hundredths place. Ones place times hundredths place, 1 times 100 is hundredths place. So you know what? I think this has to do something when you multiply the numbers, you see, and then you count some place values. So you know what? We're going to do now the true investigation of it. So I'm hoping you're getting a little grasp of this. But if not, I would just tell you directly what's the rule. 12, without using a calculator, answer each one. 12 times 3 is 36. 8 times 9 is 72. What is 24 times 13? That's 12. Carry the 1. That's 6 plus 1 is 7. 4, 2. So it's 312. 24 times 18 is 3. That's 16. 19. That's 4. That's 2. 2, 13. 432. Now, using a calculator, what would each one be? Using a calculator, this would be 36 hundredths. Using a calculator, this would be 72. So this 36 thousandths, I'm sorry, and this will be 72,000. Using a calculator, this one will be 312 ten thousandths. Whoops. Using a calculator, my brain is 432. Be that one right there. So the question is this: what is similar about the 2 rows? This one share 36. This one shares 312. This one shares 72, 432. So they share part of the product. So they share the same numbers in the product. What is different about it though? The first 2 rows are all whole numbers. The last 2 rows are all decimal. So it's whole numbers versus decimal. What decimal point patterns do you notice in the problem? In this one, let's look at this. Here's a decimal point. It seems like there are 3 numbers behind it. Here, I see 2 numbers here behind it and 1 number behind it. So in total, there are 3 numbers behind it. Another way to think of it is this. This is the hundredths place. This times the tenths place. 100 times 10 is thousands place. Is this in the thousandth place? It is. Next one. 9 times 8 is 72. There are 3 places. This is in the thousandths place. There are 3 numbers behind the decimal. In my value product, there are 3 numbers behind the decimal. Another way to think about it is, this is the hundredths place, this is the tenths place, 100 times 10 is thousand place. Next one. There are 4 numbers behind the decimal point. Here, are there 4 numbers behind the decimal point? There are. Another way to think about it is, this is the hundredths place times the 100 place. It will be 10,000th place. This is the 10,000th place. Some people like doing that using the place value to help them. Other people like counting the number of places behind the decimal point. It's up to you. So, how do you multiply? There's 2 ways. You can multiply normally, ignoring the decimal point. Then you put the decimal point in the answer. The answer should have the same number of decimal places as in both the numbers you are multiplying. For example, 5.1 times 1.3 is 6.63, or 6 and 63 hundredths. So 5 and 1/10 times 1 and 3/10 is 6 and 63 hundredths. How many numbers do you see behind this decimal? 2. There are 2 numbers behind the decimal. Let's look at this one. 2 and 4/10 times 12 hundredths equal 288,000. How many digits are behind this decimal point? 3. How many digits are behind these decimal place? 3. Another way, this is how I like doing it. A lot of kids don't like it this way, but this is more of the mathematical reason. You're multiplying by the tens place. You're multiplying by the tens place. Tens place times tens place is hundreds place. You're multiplying by the tens place. You're multiplying the hundred place. 10 times 100 is 1,000 place. So let's try this one. So you have 25 hundredths by 2 tenths. So we multiply normally, pretending there are no decimal, and I got 50 hundredths. How many digits are behind the decimal point? 3 digits. So I need 3 numbers behind her. Do I put it here? Behind here? No, because that would be the same thing. Like nothing has changed. So we put it in front of it. Some people do the little humps. 1, 2, 3. So 50 thousandths. Another way to think about it is this is the hundredths place. This is the tenths place. 100 times tenths place is 1,000. This is 1,000 place. Some kids do not like it this way. Other kids say, but last year, 5th grade, my teacher told us we line up the decimal point. Fine. If you really want to line up the decimal point, I'll let you line up the decimal point. So what do I go here? I fix a placeholder, 0. You just multiply the word, 0, 0, 0. Smiley face, my placeholder. That's 10, carry the 1, that's 5, that's 0. And these are all going to be 0, 0, 0. If you add this up, you get 0, 500. But how many digits are behind these decimal point? 4 of them. So it's 0.00500. Same answer as that. So if you like lining up, line it up. Add, fix some 0. Some people say, too much work. I'd rather just multiply it as whole numbers and count. Next one. So we have 10.2 tenths, 10 to 2 tenths times 22 hundredths. So if you would like to multiply just like regular whole numbers, go ahead. This is for those who like it this way. Tens, hundreds, thousands. So it's 2 and 244,000, 3 places behind it. Some kids say, I don't like it that way. My teacher told me to line it up. Fine, we'll line it up for you. Fix a placeholder there. So that's 0, 4, 0, 2, placeholder 0, 4, 0, 2. Let's add it up, 0, 4, 4, 2, 2. 4 numbers behind it, 2, and same exact answer. All right, let's do our last question for today. Greg bought 8.12 gallons of gas at $2.02 per gallon from Costco Gas. Estimate and find exactly how much did he spend. Let's estimate first. So 8 to 1,200 is he bought about 8 gallons at $2 per gallon. So each gallon costs $2. 2, 4, 6, 8, 10, 12, 14. So he spent about $16 if you estimate. Exact now. So if you want to multiply these, you can multiply to pretending they're whole numbers. And we'll go back and put a decimal point. It's 4, that's 2, that's 16. You add it up, 4, 2, 10. And how many numbers or digits? Tens, 100,000, 10,000s. Right there, 6. So about $16.40 or rounding, estimate. So and that's a good estimate. Some of you are going to say, but Mr. Joe, my teacher told us to line it up. All right, let's line it up. 4, 2, 16, 0, 0, 0. 4, 2, 16. If you add this up, 4 places, same exact answer. So about $16.40. And this is the study of how to multiply decimals.